Hello everybody, welcome to the first day of the final unit. It's going to be polar coordinates and equations. For today we're going to look at converting polar coordinates with rectangular coordinates back and forth and getting a good understanding of what exactly a polar coordinate is. So I'll kind of say it out loud first and then we'll go through an example here. The idea is that you've always plotted points, right? The order pair 3, 4 on a rectangular grid where you'd go over 3 and up 4. Well, there's another way you can do it too. It's over a polar axis, and you can describe a point by its radius, how far away from the origin it is, and the angle it would take to get there. This is very similar to vectors in the idea that x is equal to r cos theta and y equals r sine theta are both going to be used, as well as the other formulas we used back in that chapter. So, here's the idea. It's a system that expresses ordered pairs in terms of the distance from the origin, which we'll call a pole. So the pole, whenever you hear that phrase, is basically the origin, the intersection there, and the general angle that leads to that point. So we're going to have the same general angles that we've always dealt with. So if you look at this, we have 0 degrees here. We go by 15s this time, so 15, 30, 45, 90, 180, 270, all the same degrees and radian measures that you've always had. So, in this first example, the ordered pair is 6, 2 pi over 3. So it goes r, theta. So the angle is 2 pi over 3, and it goes out 6. So we find 2 pi over 3, which is right here, and we go out 6 units. Each of the circles represents 1 unit away. 1, 2, 3, 4, 5, 6. And at this point here, we express it as a ray, though. That is one of the big differences that goes out to that point. So, the r value, in this case, can also be negative. Like if you look down here, the ray just goes in the opposite direction. So negative 6, 5 pi over 3. 5 pi over 3 is right here. So normally it would go in this direction, but since it's negative 6, it would go in the exact opposite direction, which ends up being that point there. So in that way, one specific point array can be expressed in an infinite number of ways with both positive r values and negative r values. Okay, moving on to converting now. We're going to convert from polar into rectangular and then rectangular into polar. And we're going to use those same formulas that we've used in the past. So in this first one, the r is 4, and the theta is 3 pi over 4. So that would be basically that. Let's see if our equations get us something that looks like it should be there. 4 times cosine of 3 pi over 4. Cosine of 3 pi over 4 is rad 2 over 2. And that ends up being 2 rad 2, and be negative, so negative 2 rad 2. The y value is going to be for sine 3 pi over 4. The sine value is positive, so this is going to be 4 times positive rad 2 over 2, which is also 2 rad 2, making our ordered pair negative 2 square root of 2, 2 rad 2, which is looking like that is correct. Okay, over here, negative 3, 7 pi over 6. So normally 7 pi over 6 would have been going this way, but because it's negative, it ends up over here. So we can tell that both of our solutions are actually going to be positive answers here. Now this actually ends up working out naturally with the way the signs work out. X equals negative 3 cosine of 7 pi over 6. 7 pi over 6 would have had a rad 3, 1, and 2 there. Those would have been negative. So the cosine value would have been rad 3 over 2. So we get 3 rad 3 over 2. The y value, negative 3 sine of 7 pi over 6, is negative 3. Sine of 7 pi over 6 is a little bit nicer of a number, negative 1/2. So we end up with 1.5. Making our ordered pair, if we convert 3 over 2 to 1.5, we have 1.5 rad 3, comma 1.5, and it makes sense that both of those are positive since we ended up in the first quadrant. Okay, now for these class examples here, we have 3 comma negative 4. So if I plot 3, negative 4, I can see that is where the point is. So it's going to be somewhere around 300 degrees or so, roughly. We're going to find out the exact measure shortly. So first, the r value. R is going to equal the square root of x squared plus y squared. And you could probably see what's going to happen with this problem already. It's a Pythagorean triple. That same Pythagorean triple we've always used. And we get an r value of 5, right? 3, 4, 5 is the r value. The theta value is going to involve this formula right here. If tan theta equals y over x, theta would equal y over x. So theta equals, and I always treat these as positives, inverse tan of 4/3. So we go to the calculator, second tan, 4 divided by 3. This gives us 53 degrees. That 53 degrees is this degree measure right there. So we could call this negative 53 degrees, or if we want to express it in terms of between 0 and 360, we would do 360 minus that answer and get 306.9. So our ordered pair would be 5, 306.9, and depending what angle you use there are an infinite number of ways of expressing that. Okay, negative 2, negative 6. 1, 2, 1, 2, 3, 4, 5, 6, right there. The r value is equal to the square root of 2 squared plus 6 squared, so that would be 4 plus 36. R is equal to square root of 40. Let's rationalize that to 2 rad 10. The theta value here, that's 6, that's 2. So theta is going to be equal to the inverse tan of negative 6 over negative 2. That's 3. So if I do inverse tan of 3, I get 71.6, let's call it. Now that is once again the reference angle. So that is the angle right here. To get the general angle, we'd go 90, 180, and then we'd add that 71.6. So theta is going to be equal to 180 plus 71.6, which is 251.6 degrees, making our final polar coordinate 2 rad 10, 251.6 degrees. And that is how you convert. On the next page, I have 7 textbook problems I'd like you to try for practice today. And then next time we'll get into polar equations as well as polar coordinates. Thank you, and please email or put into the discussion any questions you may have. Talk to you later.